I'd like to share some thoughts with you on the topic of data-driven storytelling, because normally there is three stories people are telling when they're talking about big data. The first one is this famous definition with the 4 V's: volume, velocity, variety, and variability. So big data is large, obviously. It's very fast. It has many different ways. It's unstructured. And lastly, it's changing. For example, the APIs are changing, so the data is changing. It's evolving. This is the first story. It's the most common story about big data. The second one is more about the organization perspective. So there's a new set of skills, a new job description that's rising right now. That's the chief data officer, chief data scientist, and so on. So it's about developing data products in organizations. And then there is also a third story, and this is the like data science, the subject matter story about algorithms, machine learning, predictive analytics, as we just heard, large-scale machine learning, the new tools of the trade, for example. So, most big data stories or big data cases are trying to predict something like the click rate, or finding out socio-demographic features, and then doing a test, and then you know how well you predicted. And I think this is very nice stories, but there is another story hidden in big data, and this is the thing about big data as storytelling, because I think it's one thing to do this scientific approach to, you have an hypothesis, for example, that certain users are more prone to click on certain ads, and then you try to verify it and try to learn from it. But the other thing is you have a vague mass of data points, and you're trying to find out if there's an interesting story hidden inside. And these three gentlemen, it's unfortunately a very male slide. I'm sorry for it. Are the kind of the saints of storytelling with data. It's Jacques Bertin who came up with some very basic ideas on how to do like a grammar rules for data. He was working mostly with maps, so he came up with things like what you can vary to make a message in a visualization clear. For example, you have the shape, you have the value, you have like direction, you have arrows, for example, and it's very valid still. It was done 40 years ago. Then John Tukey, who's the inventor of many very common tools in statistics and data science. For example, he invented the box plot, and he also he wrote a book on exploratory data analysis, and this is still one of the most important books for me when it comes to, here's a data set, find a story in the data. And he was working on these topics when there were no computers, there was no Amazon available, so he did it with a simple pencil and a pair of scissors. So one of the nice stories was he had a data set from a survey, for example, and you have like few hundred respondents, and you have some questions you're asking about what's your sex, what's your age, and so on. And he was looking for ways to find patterns in the data, and so he just took a very, very large piece of paper with different rows, and each row was a case, and then he made some other columns, and each column was like a variable or a for example, there were 2 columns. The first was for male, the second for female, and then there were like 10 different age categories. And then he took the pencil and he draw the squares on the paper. And then he took the scissors and cut all the cases. And then he shuffled the data strips until there was some pattern. Like here is a very clear black field. There's some people that are very similar, and here's another black field, so people are similar here. And this is, we don't have to do this with paper anymore. We have computers to do it, but many of the approaches are quite similar. And then finally, Edward Tufte, who is right now, I think, one of the most famous information visualization guys in the world, who invented, for example, the spark line, this famous little thing you're seeing on when it comes to stock quotes, for example. And I think they all they had the same question. They had unstructured data and had to find some patterns in the data. And this is exactly what's happening with big data. And now I'd like to give you some examples of nice stories hidden in data. So this is a very recent example, which is very interesting because there's an obvious political dimension. It's from the elections in Russia, and they had there was protesters, and they had this sign that says, "We believe in Gauss, we don't believe in the election office," and they painted the results of the election, and those are the different parties, and the lowest one, it's Putin's party, and it's on the y-axis is the number of election election areas, and on the x-axis it's the percent the party had at these election offices, and of course it's a nice curve, but there were these bumps at every even number. For example, there's a huge bump at 50%, there's a huge bump at 60%, and so on. And this was, when you look at it from a statistical perspective, it's quite uncommon, because there should be some variation. And why should it be so much more likely that there are many election areas where the party has 50% of the votes and not 49 or 51? So this became a very interesting statistical discussion, because there were guys who said, well, maybe the guy at the election office didn't want to count all the numbers and said, well, I know it's somewhere around 80, so I make it 80, and so the 80 has this bump. Or maybe it was like a message from them, a hidden message. Here's some patterns. Maybe someone can decipher them and has some kind of a subversive message to take a close look at the election. So this is I think a very interesting story about data visualization in a very obvious political way. The second thing that's a visualization we did, and it's very colorful, looks nice, but there's another story hidden in this. And what we did for this image is we downloaded a lot of images from Flickr, the photo sharing platform, and then calculated the distribution of the different colors. And each line is a month, and we only took German photos uploaded in Germany, and you can clearly see there is like a movement in the colors. There are clear months where there's a lot of blue colors, and then there are months where it's more like green and yellow, and actually the blue ones are the winters, the winter photos, and there's a lot of much more blue in the photos, even if they are completely random. There's photos in-house, photos on Christmas, photos of conferences, and so on, but you can still see the seasonality in this data. And actually I then calculated a correlation with the temperature data in Germany, and it's really quite high correlation of 0.87 or so with the amount of green in the color. So if you can predict or retro predict the temperature by looking at the photos shared on Flickr. This goes in a similar way. It's a visualization of mobile traffic. It's a mobile panel of people who have had a like a tracking device on their mobile. They were in a Nielsen panel, and then we collected the data points, and each line is one respondent, and this is a very simple visualization because on the x-axis it's the time dimension, so it's like half hour. Did this guy use Facebook in this half-hour slot? Yes, no. If yes, then I draw a point on this line, a red dot, and red was WhatsApp and blue is Facebook, and so you see the usage of these mobile apps in time, and this is like the homage to Tuki. I didn't cut them and sort them, but the computer did it, so it sorted all the people who were using a lot of these apps frequently on the day to the top, and the more relaxed ones that weren't looking at their mobile phone all of the time at the bottom. So it gives you an impression of how intense the usage on this platform is, like this mobile carpet. And we also printed it and did some posters to hang in the office. So it's nice. This is another visualization, something that at first looked like an artifact. This is geolocated tweets in Germany, and suddenly there was this letter H somewhere around, and I was thinking, what's that H mean? Any ideas? It's like a hidden message from space. No? This is actually the Munich airport. There's the two terminals, Terminal 1, Terminal 2, and the train station in between. So it's a very nice looking H, and then you can delve deeper on these dots, and each dot is, of course, a Twitter message of someone who is waiting for a train, waiting for the plane, or there is even some of them who are tweeting while on the runway, which wasn't allowed at that time. Now it's allowed, but you can see those runway tweets as well. So there is a lot of strange things hidden in data, but they also tell a nice story. And this is a very recent episode that's very nice story on the intersection of the Internet of Things, data science, and algorithms. Those are two quite famous bots on Twitter. The first bot is called Pixel Sorter, and the second one is called QuiltBot. And what these guys are doing is, if you are posting a picture on Twitter and you're addressing it to Pixel Sorter, for example, then this bot will take the picture and do some sorting on the pixel and return the new image. And QuiltBot is another bot that's taking your picture and doing kind of a quilting with this quilting pattern with this. And then suddenly on the 23rd of September, these two bots were talking to each other. So Pixel Sorter sent an image to QuiltBot, and QuiltBot quilted it and returned it. And those are the first 6 of this conversation, and they were very fast, not in the millisecond range, but it was really every second there were new images by those two bots. And then I think the owners or the programmers stopped them after thousands of images that were generated, because otherwise Twitter would have shut these bots down. And the result is really just can do a Google search for these two guys. It's really a nice conversation, and this is the interesting things is normally you would expect that they would converge on somehow on a gray mass, and there would be no image anymore. But these two bots, they have a nice way of interaction. So there's always an image, and the image changes over time, and it's really fascinating. And maybe that's another vision for for data science that at some point of time we humans can just sit down and watch the bots do the talking or do the machines do the talking, and we just watch. So this is also very interesting and fascinating story of that obviously two machines are telling, and we just have to listen to this story. And then just finally, let me show you 3 tools I think that are very useful in telling stories with data. The first is Google Correlate, which is like the greatest machine to find very strange things. It's just you can draw some kind of a weird line, and then the tool is looking for search queries that match this line, and it always finds something, because for each way you draw a line or you upload data, there is something that's highly correlated. And this is, for example, a very obvious correlation between statistics and vegetarianism. I couldn't find I have no idea why these are so correlated. So you find a lot of false things that are interesting, that are not the truth you are looking for when doing big data analysis, but there are things you can tell stories about, and that really gets you going to take a look at all the associations a machine like Google Correlate is doing with your words you're feeding it. And the next thing that's really useful is Gephi, where you can also upload your data, and it's a tool that's running on your desktop computer, and you can use it to do some very easy. It's like the Photoshop for network analysis. You can feed it data and visualize it in terms of a network structure. So here is a Foursquare network structure of this is, I think, the Austrian city of Linz, and you see these locations that are very central in terms of people visiting it or checking in on Foursquare. There's the Hauptplatz, of course, and then you can have also some you can use algorithms to tell stories. For example, this is based on the Pagerank algorithm, and the Pagerank algorithm that Google also used is the story behind it is, if you drop someone in Linz and this person is very disoriented and is just walking, just following the flow, let's say, just the most frequently visited Foursquare location after my location. And then this is the places where this person will land. So it's like a drunk people walking around Linz will always end on the Hauptplatz or at the Passagen in the city center. And in Munich, for example, it's the Hofbräuhaus and the Viktualienmarkt. So each city has kind of traps where people land when they were walking around without thinking and looking. Yeah, and the third thing that's really wonderful innovation in terms of data-driven storytelling is the Ipython notebook. That's a technology that allows to run your programs in a browser window, and you can have text in there, you can have code in there, and you have the results. For example, this is I took a look at Google research papers and did some cluster analysis to find out which topics are most frequently used at the research department in Google, and you can compare this over time and find out which topics are right now are very hot for research. And the nice thing is you can share all these notebooks, and if you Google it, there's like a search engine for Ipython notebooks, and you don't have to be a programmer, you don't have to have Python on your computer. You can just take a look at these stories people are telling with code, with words, and with infographics. So this is, I think, a glimpse of the future of data-driven storytelling, and there's every topic you can find Ipython notebooks, whether it's fashion images, or of course cluster analysis or mobile data. You can find everything you wish or you wouldn't wish on this search engine. So this is science communication with stories and images. So thank you very much for your attention and for listening to my thoughts about data-driven storytelling. And I'd like to know from you if there's something you'd like to add or some questions. So, yeah. Well, it's a very long story. Could do a talk on this, but I think one of the connections to this topic is that in companies there's two ways of using big data or using data analytics. The first thing is they have some hypothesis on their public, for example, on the customers, and want to prove them by data, for example, that certain people are buying more items than other people, and then they learn from the data. And either it proves this hypothesis right or wrong. And the other thing is someone has an idea, and then the challenge is to look in the data to find some story that goes in this direction. And this is more this way of data-driven storytelling, because basically when it comes to this network structures, there's a million ways the result could look like, and every time you run this algorithm, the network has a little bit a varied structure. So you have to find a structure that really helps you tell the story, and this is the way data is used in many organizations. It's not in this way data is used to prove some hypothesis, but it's used to tell my story with better visual evidence, for example. So big data, in a way, can be like content marketing, or can be a content marketing in companies. So, any further questions? Yeah. Yeah, it really depends. It's I think if there's connections between things, then this approach of doing network visualizations with Gephi, for example, is very nice, and it's really very powerful. If there are things that have connections, for example, people who use the same product or who visit the same website, then you have this kind of structure. You have some nodes and some connections between them, and this fits very well. And in other cases, yeah, with the Ipython notebooks, you can basically do anything. It's if you tell story with code, data, and images, then this is a very very nice tool. So it really depends on the kind of data and the story you want to tell. Okay. If there are no further questions, then thank you very much.